rest of the history of physics. Classical physics. Physics became a separate science when early modern Europeans used experimental and quantitative methods to discover what are now considered to be the laws of physics. Major developments in this period include the replacement of the geometric model of the solar system, with the heliocentric Copernican model. The laws governing the motion of planetary bodies, developed by Johann Kepler between 1609 and 1619, pioneering work on telescopes and observational astronomy by Galileo in the 16th and 17th centuries, and Isaac Newton's discovery and unification of the laws of motion and universal gravitation that would come to bear his name. Newton also developed calculus, the mathematical study of change, which provided methods for solving physical problems. The discovery of new laws in thermodynamics, chemistry, and electromagnetics resulted from greater research efforts during the Industrial Revolution as energy needs increased. The laws comprising classical physics remain widely used for objects on everyday scales traveling at non-relativistic speeds, since they provide a very close approximation in such situations in theories such as quantum mechanics and the theory of relativity, simply to their classical equivalents at such scales. However, inaccuracies in classical methods for very small objects and very high velocities led to the development of modern physics in the 20th century. What would you like to ask? Go on.
You're right.
What am I doing?
High school physics book.
No, I'm reading the history of physics on Wikipedia.
Okay.
I will now be going on to modern physics, which is the
All right,
most
mate.
recent. Modern physics began in the early 20th century with the work of Max Planck in quantum theory and Albert Einstein's theory of relativity. Both of these theories came about due to inaccuracies in classical mechanics in certain situations. Classical mechanics predicted a varying speed of light, which could not be resolved with the constant speed predicted by Maxwell's equations of magnetism. This discrepancy was corrected by Einstein's theory of special relativity, which replaced classic mechanics for fast-moving bodies and allowed for a constant speed of light. Black body radiation provided another problem for classical physics, which was corrected when Planck proposed that excitation of material oscillators is possible only in discrete steps of proportional to their frequency. This, along with the photoelectric effect and a complete theory predicting discrete energy levels of electron orbitals, led to the theory of quantum mechanics taking over from classical physics at a very small scale. Quantum mechanics would come to be pioneered by Werner Heisenberg, Erwin Schrödinger, and Paul Dirac. From this early work and work in related fields, the standard model of particle physics was derived, following the discovery of a particle with properties consistent with the Higgs boson at CERN in 2012. All fundamental particles predicted, that's my phone, by the standard model, and no others appear to exist. However, physics beyond the standard model, with theories such as supersymmetry, is an active area of research. Areas of mathematics, in general, are important to this field, such as the study of probabilities and groups. The end. How do you like that? Oh yeah.
You kind of sound like you're